Hi everyone. This part of the lesson that I want to focus on is having a triangle in the coordinate grid, and we have E at -2, 4, F at 0, 6, and D at 4, 0. And finding the coordinates of some of those special points we had inside the triangles, or even outside the triangles, like the centroid. Now it's somewhat involved, so bear with me. Stop it and pause it where you need to pause it, but let's go for it. We're going to go centroid first. Centroid is where the medians meet. And in your foldable, you'll probably look at medians and say, somewhere I hope it says it connects an endpoint, or a vertex, I'm sorry, to a midpoint. So we got to find the midpoint. Let's find the midpoint of FD and connect it to E. The midpoint of FD. So I'm going to, if you recall, add the x-coordinates, 4 plus 0. Here's an x-coordinate of 4, an x-coordinate of 0, and divide by 2. And add the y-coordinates, 0 plus 6, and divide that by 2. 4 divided by 2 is 2. 6 divided by 2 is 3. 2, 3. Does that look like the midpoint of FD? I think so. I'll bet you do too. Let's draw that median. And I'm going to call that midpoint M. And connect E to M. And I want to draw another median. And so I'm going to find the midpoint of ED. 4 plus, I'm calling that M, 4 plus -2, divide that by 2. 0 plus 4 divided by 2. 4 plus -2 is 2, divided by 2 is 1. 0 plus 4 is 4, divided by 2 is 2. I'm going to call this point N. 1, 2 is right there. I'm calling that point N, and I'm going to connect that to F. Okay, that point right there is the centroid. Now, just for the heck of it, if you'll look, do you see that that point right there, going up 1 over 1, up 1 over 1, that is the midpoint. I'm going to call that point O. And point O is at -1, 1, 2, 3, 4, 5. I'm not doing all the calculation this time because we just did that one by looking at it. And when I draw, notice how it goes right through that same point that those other two went to. That is the point of concurrency. That is the centroid. And we want to find the coordinates of the centroid. We'll call that point C. The way we're going to do it is this. One of the ways, and this was an Algebra 1 technique, and it'll be an Algebra 2 techniques, to find the point of intersection between two lines. You take the equations of those lines and you solve a system, and that's the plan here. So what I'd like to do is I'm going to find the equation of line EM. Now EM has point E at -2, 4. And it has a slope of, I'm going to go down 1 and over 1, 2, 3, 4, a slope of -1/4. -2, 4. So a slope of -1/4. So to find that equation, I'm going to plug the x-coordinate and the y-coordinate into y equals mx plus b, and I'm also going to plug the slope in since I know it. So I'm going to put 4 equals -1/4 times -2 sorry, plus b. -1/4 times -2, that's +2/4, which is 1/2, plus b. When I subtract 1/2 from 4, I get 3 1/2 is B. So the equation for line EM is y equals negative 1/4 x plus 3 1/2. There you go. That equation right there. 1, 2, 3 1/2. That looks very reasonable to me, that 3 1/2 is the y-intercept. Now let's do another one, and I don't think we have to work quite as hard on the next one. I'm going to choose, and I don't even think it matters which one I choose. I'm going to choose FN, line FN. I'm going to do that by sight. I don't think I have to go through all this. I have one equation. I want the other equation, line FN. Its equation, I see the y-intercept 1, 2, 3, 4, 5, 6. It is at 0, 6 is point F. That's your B value. B is 6. Your slope down 1, 2, 3, 4 over 1. Your slope is negative 4 over 1, which is plain old negative 4. Okay, so I don't have to go through all this because I know what the slope is, negative 4x plus the y-intercept of 6. So I have two equations. I only need two of them. I could do the third equation. Which one did I not do? There's EM, FN, OD. I could do that one. I'm not going to. I'm just going to use these two. And I'm going to solve the system of equations in order to find the point of intersection. And if I find that point of intersection, I find the coordinates of the centroid. If I have both of them equal to y, I can substitute. I can put this in place of this y here because it's equal to that y. This is the same y. So negative 1/4 x plus 3 1/2 equals negative 4x plus 6. Now here's my question. I'm thinking about not dealing with these fractions anymore. 4 and 2 have a least common denominator of 4. If I multiply the whole equation by 4, I won't have any more fractions, and that might be something you like. 4 times negative 1/4, those 4's cancel out, so that's negative 1x. 4 times 3 is 12. Half of 4 is 2. 12 and 4 make 14. 4 times negative 4 is negative 16x. 4 times 6 is 24. Okay, this equation and this equation have the same solution. Which one would you rather solve? That's what I thought. So I'm going to add 16x to both sides. Add 16x to both sides. I've got 15x plus 14, negative 1 plus 16x, is equal to 24. I'm going to subtract 14 from both sides. I've got 15x equals 10, and divide by 15. Just occurred to me that you're not seeing what I just wrote. Just take a look here. Just pause it and catch up if you need. 10/15 is 2/3. 10 divided by 5 and 15 divided by 5. That's 2 over 3. So the x-coordinate of point C is 2/3. The y-coordinate, I'll use this or I'll use this. And I'll probably just use this one right here. The y-coordinate is negative 4 times 2/3, that value we have for x, plus 6. Negative 4 times 2 is negative 8, so it's negative 8/3 plus 6. Now that is negative 2 and 2/3. 3 times 2 is 6 plus 2 is 8, plus 6. 6 minus 2 is 4. 4 minus 2/3 is 1/3. Negative 2/3 plus 6 is 3 1/3. So I do have the coordinates of the centroid, 2/3 and 3 1/3. Let's see if that looks reasonable. Over 2/3, up 1, 2, 3 1/3. That looks very reasonable. I'm certain that 2/3, 3 1/3 is the coordinates of the centroid. All right, I want to do one more. I'm not going to get the other one done, but But let's, at this point, focus on the circumcenter. It's the same problem, or same triangle. It's not going to be at the same place, I'm pretty sure. We're going to focus on the circumcenter. Now, the circumcenter happens when the perpendicular bisectors are drawn from each side and where they intersect. So, I know the midpoints. I already did that on the other side. This one, the point was right here at -1, 1, 2, 3, 4, 5. This is the midpoint. Remember, I called that one O, I think. Let me look at the work I just did. No, yes. Well, I didn't even name it. Called that one point O. Oh, it's on this side. Where did I write that? Yeah, that's point O. Let me find the midpoint here. We already talked about that one. What do we call that one? We called that one point M. May as well not change it. And the other side, point N at 1, 2. Right there. Point N. Now, we're talking about the circumcenter, which connects the perpendicular bisectors. Okay, do you remember we found the slopes of these? The slope of EF is up 2 over 2, or just 1. The slope of the perpendicular, flip it over and make it negative. So that slope is -1. So if I go down 1, right 1, and draw that clear through, just so happens that that perpendicular bisector is also, for that segment, is also the problem we drew for the median. That didn't happen on the other ones, though. All right, so I have this one, and I'm going to use this one to find the equation. I'm going to use OD because I didn't use that on the other one. The slope of this one, down 1, 2 over 1, 2, 3. The slope of ED is 2/3, -2/3. Went down 2 and right 3. Okay. The slope of that perpendicular is going to be +3 over 2. We got to flip it and change the sign. So I'm going to go up 3, 1, 2, 3, and over 2, 1, 2, right there. And down 3, 1, 2, 3, 1, 2, 3, and over 1, 2. Okay, so I'm going to draw that perpendicular bisector right there. All right, so that's perpendicular and it's bisecting. And from here, I want to draw a perpendicular bisector. And the slope here of this line, 1, 2, 3, 1, 2. The slope is down 3 over 2. And I want to flip that, make it 2/3. So I want to go up 2 and over 1, 2, 3. Down 2, 1, 2 over 1, 2, 3. And draw that one. Okay, so I've got my 3 perpendicular bisectors drawn, and they're all crossing right there. Does that look perpendicular? I think so. So, what we need are equations again. All right. I'm going to write down the equations. We're going to have to finish this in class. I'm going to run out of time. So, the equation for... Let's do the equation for OD. The y-intercept is 1, 2, 3, 4. The slope is -1, -1x plus 4. That's the equation for OD. I need to find an equation, and we will continue in class. We're just going to have to finish this in class. All right, bye.